All right, this is the Geometry Unit 4 Lesson 2 video. This lesson is all about classifications of triangles and some properties of the angles of triangles. So the first thing I'm going to go over in this lesson is the different categories of triangles, triangle types, basically. What different ways can triangles be shaped, oriented, and then we'll talk about some of the other characteristics that we need to know about. So in general, write down classifying triangles. So in general, when we classify triangles, every triangle can be classified in two ways. Every triangle is going to have a classification based on its angles and a classification based on its sides. So we're going to talk about angles first, and then I'll go around and do sides as well. So classification based on angles and a classification based on sides. So classification based on angles is going to be based on whether or not there are certain types of angles in the triangle. And these are things we've covered back in Unit 1 and 2. So for instance, one type of triangle would be an acute triangle. Acute triangles are triangles where you have three acute angles. So all three angles are acute. So that's your first triangle type based on angles. Next will be a triangle in which you have a right angle. So those are called right triangles. So you can already see the angle names are closely related to the triangle names. So if it has a right angle, it's a right triangle. And right triangles have just one right angle. And in a second, I'll kind of discuss kind of a little bit more detail about this. But one important thing to remember is triangles can only have one right angle. They can't have more than one because there's no way for those angles to fill the triangle. They're too much if it's more than one right angle. All right. Next is obtuse. Again, closely related to obtuse angle. It has one obtuse angle. All right. So those are your kind of three main triangle types dealing with angles. There is one other one, but I'm going to save it for the end and you'll understand why here in a minute. So we have acute triangles, which have three acute angles. We have right triangles, which have a right angle, and obtuse triangles, which have an obtuse angle, and just one obtuse angle. They can't have more than one. Okay, so on the other side of this, we have triangles that we have classifications that are based on the sides. So one would be triangles that have three different side lengths. So these three sides, none of them are the same. This is called scalene. So scalene triangles have three different side lengths. All right. So three different side lengths means it's called a scalene triangle. Then we have triangles. I'll actually draw two examples of this. These are going to be what we call isosceles. One pair of congruent sides. So isosceles triangles have one pair of congruent sides and another side that is a different length. I went ahead and drew multiple examples so you could see how differently they can look. And so those are the main two triangle relationships when it comes to sides. Now, I left one section down here that kind of crosses over both because there is a triangle type in which we have all three sides and all three angles the same. And that is on the angle side called equiangular, and on the side equilateral. So the reason I'm writing these kind of together down here is that these two always come together. You can't have an equiangular triangle that is not equilateral. They are always together. So all three angles are congruent, and equilateral refers to all three sides are congruent. All right, so just to recap, we have three ways to categorize the angles of a triangle. Triangles can be acute, meaning they have three acute angles. They can be right, which means they have one right angle, and they can be obtuse, which means they have one obtuse angle. They also are categorized based on sides. If there are three different sides, then that's called scalene. If there is one pair of congruent sides, that is called isosceles. And then, of course, if the triangle has all the same angles and sides, they are equiangular and equilateral, and that is kind of its own category that crosses over between the two. So that is kind of one of the main concepts in this lesson. So I've covered most of the material up here at the top. And then they go through some information about triangle angles. So the first thing you need to know, and kind of one of the key things here, is what we call the triangle sum theorem. Triangle angle sum. And that is that all triangles have a sum of 180 degrees. Angles add up to 180 degrees. All triangles have angles that add up to 180 degrees. Then there are some corollaries or some other ideas that grow out of that theorem. And so I'm going to run through these one by one and kind of explain to you what they mean. So I've already put them on our notes here. So let's go to 4.2a. It says, the acute angles of a right triangle are complementary. Well, why is that? Let's talk about it. Well, if I have a right triangle, I already know that this angle is 90. So if one of those angles is 90, and I subtract that 90 degrees, that means that there is only 90 degrees left for the other two angles. So naturally, those other two angles have to be less than 90, which automatically makes them acute. Not only that, they have to add up to 90, which makes them complementary. So the other angles of a right triangle are automatically complementary. So that's kind of the key idea there. All right, let's jump over here to this next one. It says here the measure of each angle in an equiangular triangle is 60 degrees. Again, pretty straightforward. You have three angles. They're all the same. So then the only way to find out the measure of those is to divide 180 into three parts, and that equals 60 degrees. And that is why the angles of an equiangular triangle are automatically 60 degrees, because they are each equally dividing up that triangle. I already discussed this a little bit earlier, but a triangle can contain no more than one right angle or one obtuse angle. Very simply, once you have a right or obtuse angle, you've already used up half or more than half of your 180. For instance, if you have a right triangle and you take up 90 degrees with one of those angles, there's only 90 left to make up the other two angles. And if you have an obtuse angle and you say it's 120 degrees, now you only have 60 degrees left to make up that other angle. So only one obtuse or right angle can be made up in a triangle. Then we have the exterior angle theorem. The measures of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angle. Here's where we get that. All right, so let's say we have this triangle. We'll call this angle 1, angle 2, angle 3, and then we'll call this angle 4. We know that angle 3 plus angle 4 equals 180 degrees because they are a linear pair. We also know that angle 3 plus angle 1 plus angle 2 equals 180. That's because they are a triangle. So naturally, if you just use common sense, that means that if I take out the angle 3's, these parts have to be equal to each other. So then angle 4 equals angle 1 plus angle 2, and that's exactly what's being described in this theorem. Last one. If two angles of a triangle are congruent to two angles of another triangle, the third angle of the first triangle will also be congruent. I don't really know how else to explain this except to say if you got 180 degrees and two of your angles are already equal, there's only one number that that third angle can be, and that's what this theorem is stating. All right. Let's jump over to the lesson and kind of look at a couple things, and then I'll do the proofs down at the bottom for you guys. So we've got a bunch of vocab at the top. Use the words at the top to answer that. That gets you to number 11. Starting at number 12, 12, 13, 14, 15, and 16, you have the 5 options for the theorems. These theorems are the theorems I went over here on the notes. So you need to decide which theorem is being illustrated by the example. So like in this first one, which theorem or corollary could be used to prove the conjecture angle 3 is equal to angle 1 plus angle 2. So you need to go back and look at what I went over and decide which of these theorems is being shown in that example. Same thing with number 13 through 16. So I'll tell you right now, each one is going to be used once. So you have 5 options, 5 questions. Don't put any answer twice. Each one will be used one time. All right. Starting at number 17, we have some proofs. So I'm going to go over these for you guys, talk through them, and you just need to answer them in your lesson so that you get these right. You're not responsible for proofs on the test. Okay, so in this proof, it says triangle ABC is equiangular. Well, we know that that's the given, so we're going to put that as the answer here. That is given. We are given the fact that ABC is an equiangular triangle, and they want us to prove that the 3 are equal to 60 degrees. Well, we know that angle A equals angle B equals angle C, and that's just the definition of equiangular triangle. That is actually what an equiangular triangle means. It means that the 3 angles are the same measure. We also know that angle 1 plus angle 2 plus angle 3 equals 180, and that comes from the triangle sum theorem. We know that the measure of each angle, or the 3 angles, adds up to 180. Then we substitute angle A in for both B and C. That's substitution property of equality right there on number 4. Then we use algebra to say that 3 angle A's equal 180. And then we divide that 3. And so that's going to be the division property of equality. And then that gets us down to the fact that angle A equals 60 degrees. Therefore, all of the angles equal 60 degrees. So make sure you get that down. You need to answer that so you have the correct answers in yours. And then let's look at the proof for number 18. Complete the proof. Given is that triangle MNO and triangle PQR are there, and that angle M and angle P are congruent. Angle M and angle P are congruent. And angle N and angle Q are congruent. And they want us to prove that the other angle is congruent. All right. So we have our givens there in line 1. Then it says N plus O. M plus N plus O equals 180, and P plus Q plus R equals 180. Well, that is just the definition or that is just the triangle sum theorem, because we know all triangles, angles add up to 180. Then they do subtraction on both sides, and they subtract two of the angles. So they're subtracting M and N, and they're subtracting P and Q, and that gives us what we see here. So that's the subtraction property of equality. Then they do some congruence with M and P and N and Q, since those were told to be congruent up in line 1. So they're taking this from line 1, this right here. Let me do a different color. They're taking this right here, and they're bringing it down to here. And then they do some substitution by substituting the corresponding angle. So P and Q get substituted. That shows that those two are congruent. We can see that they both equal the same thing. And so that's going to be the substitution property of equality. We're substituting the value for O and R. We're substituting so that they're equal. And then that's the definition of congruent angles to prove that the two angles are congruent. And that's what we were trying to prove. All right, so that's the end of those proofs. Make sure you get those answers down. I think you have everything you need to answer the other questions in the lesson. So please reach out to me if you have more questions or need help.